online physics students, welcome back again. Physics lesson. In the past we have seen case 1 and case 2 of projectile motion equations. Today we will see the third and the fourth case. The third case, the object is projected upward above a height h, and the fourth case is projectile motion at a downward angle. The only difference this downward angle with the first case, that means the object horizontally thrown, is that in this case we have the angle theta, okay? We have angle theta, okay? So no need to derive some equations. For this case, for our case, let's see some derivation, okay? Let's say, assume this object is thrown above a certain height. Let's say this height ya, from this point to this point. Let's say ya. Let me again assign this point a, then at this point let me say b, okay? Finally this point let me say c, and that's this one. From this point to this point, we have h, okay? Now this object is projected upward, okay? Above a height y, okay? This is y, okay? This is the height y, okay? Now let us see the time. How can we find the time? Okay, all right. You know, the displacement in our kinematics, the displacement is equal to the initial times t plus 1 over 2 a t square, okay? In our projectile motion we have acceleration due to gravity. Again, we consider the direction and the vector physical quantities. That means the displacement, in our case we are looking for the vertical, okay? For the vertical we have what? The displacement is the change in displacement is equal to the displacement at yc. The displacement at yc, that means the displacement final. We have seen change in displacement is displacement final minus displacement initial, okay? That means for y we have displacement final at yc, at point c, okay? Minus what is the displacement initial at point y a, okay? At this point the object, this is the starting point, okay? This is the starting point, don't confuse, okay? So this is the change in displacement is equal to v naught. V naught in our case is v naught sine theta times t, okay? Because we have angle theta, okay? Here we have angle theta 35 degree, and minus 1 over 2 because this minus is because we have acceleration due to gravity, g times t square. All right, now what is the height or the displacement at point c for the vertical? The object thrown upward and then come to here, its final displacement is what? At point c, 0, okay? Minus at ya means we have ya, okay? Here we have ya, okay? So simply we have the displacement on the vertical YA is equal to V naught sine theta times t minus 1 over 2 g t square. What's left? Take YA to the right side. This implies V naught sine theta times t minus 1 over 2 g t square. My YA goes to there plus YA. Now take minus 1 over 2 gt square to r. This we can write as minus 1 over 2 gt square. This one is plus. Oh, here we have, sorry, 0. Okay, don't forget. Okay, plus V naught sine theta times t plus YA is equal to 0. Now, in your mathematics, to find the total time of flight, we have to use quadratic equation. That means we can, in your mathematics, there is a rule. We have t. To find the value of t, we use with a quadratic formula, minus b plus or minus the square root of b square minus or ac over 2a. You know this in your mathematics. So we are finding the value of t. Okay, to find the value of t, we have to put each value to quadratic equation. So according to the given values of YA, again V naught sine theta, again minus 1 over 2 gt square. So this one is a, sorry, let me write with another color. Okay, now this one over 2a. Okay, this is the quadratic formula that helps us to find the time of flight and take the positive, okay, the positive value. Okay, because we don't have time negative. Okay, so I think it's clear. Okay, so this one, in our case, the value of a is equal to minus 1 over 2 g. Okay, the value of b, this one is the value of b is equal to v naught sine theta. You have to calculate. Okay, and the value of c is ya. If you have these values, you can find the value of t by using this quadratic formula. Okay, no need to worry. Okay, all right. Okay, now this is the value of what? TAC. Okay, we have here TAC value. Okay, now what about the range? The range means the horizontal distance. Here we have the range. We can find the range by, range is calculated by V naught across the x times t across a up to c, because the total time of flight. The total time of flight, or the t, we can calculate by using the quadratic equation. Okay, and take the value positive, and we can find the range by V naught times RS. This can be written as range is equal to V naught cos theta, V naught cos theta times time of flight. Or if the value of the range is given, you can also calculate the total time of flight T up to Tc by using, if you have the range, okay, the horizontal distance, you can use range over V naught sine cosine theta. You can also use this equation if you have the range, okay. You can find the total time of flight, okay, this way. All right. What about the value of YA? For example, you may be given the total time of flight, the range, everything. If the total time of flight, the range, V naught theta, these values are given, and if you are required to find out the value of YA, you can use the following equation, okay. Let's drive, okay. That means YA. First, let's start from our kinematics equation, okay. This equation, let me write here, okay. Displacement is equal to V naught times T plus 1 over 2 AT squared. This is in our kinematics. This kinematics. So we can convert this one to our equation. That means the change in displacement. If you are now required to find out the value of YA, that means the displacement according to the vertical. To calculate that one, look the direction of YA. YA is in downward. In downward direction, the displacement is negative. That means we can substitute minus YA is equal to V naught sine theta is equal to V naught across the Y, because we are using the Y, V naught sine theta times T. Which time we are using? Total time of flight, TAC, okay, minus 1 over 2. A already we have because acceleration due to gravity we are using, and TAC square, okay. Because if these values are given and you are supposed to calculate the value of YA, use this formula, and what we can do here, we can substitute all the values. Means minus YA is equal to V naught sine theta times, what is the value of TAC? TAC is here, okay. Here we have TAC, okay. Range over V naught cos theta, range over minus 1 over 2 G, okay. The value of total time of flight R over V naught cos theta. Right. Now what's left? We can write this one as, okay, we have a space here. Sorry for the delay, sometimes it needs some attention. Minus 1a is equal to, this v naught sine theta over v naught cos theta. This one by this one already cancelled. In your mathematics, tan theta is equal to sine theta over cos theta in your mathematics. Here we have what? Tan theta times r, okay, the range, minus g times range over twice of v naught cos theta. So you can find again the value of YA by using this formula. I think you get some information. Okay. The next point is about case 4. Case 4, no problem. Just apply only. The only difference is that we have V naught can be written as across V naught across the x, it is equal to V naught cos theta. Okay, you have to substitute this one because of the angle theta. Okay, and for the vertical V naught y, we have V naught sine theta, and V naught cos already. The acceleration ax across the horizontal, for the horizontal it's already 0 because the v naught x always is equal to v final or across the x. That means it's constant. Okay, and vy already for the vertical direction v times sine theta. The acceleration here the same, which is negative 9.8 meters per second, and the vertical displacement always negative. Okay, vertical displacement negative value because it's downward. Okay, downward direction. Even for the previous calculation, you see we use negative. Okay, because the displacement y is downward. Okay, for the part we use the positive one. Okay, that is all about the 4 cases. Now let us see one example. All right, let us see this example. A cannonball is launched from the edge of sea cliff of height 72 meters with an initial speed 150 meters per second and angle 38 degrees above the horizontal as shown below. Okay, here is the diagram. Okay, already for this is the object projected upward from a certain height, that means 72 meters, and under A you are required to compute the flight time for the cannon of the ball. You are required to find. Now let us start A. Okay, take out the given. You have given theta, the angle here it's 38 degree. It's projected upward, okay, in this way, okay. And it is initial, this from this to this, let's say the initial displacement for the vertical. All right, good. And we have after projected this object at this point, we have two components, right? The first component is the vertical component. That means the vertical across the y, v naught y, is equal to v naught sine theta. Here we have again the horizontal, okay? V naught cos theta. So let's put the values, okay? Y naught, sorry, let me change my pen. Y naught is equal to 72 meter, okay? But the motion is, it's motion, the object projected upward. Now we can evaluate the values of the velocity across the horizontal. V naught x is equal to v naught times cos theta. Cos theta, which is equal to v naught is already launched with this speed, okay, 150. The v naught is equal to 150 meter per second, okay. So 150 meter per second times cos 38 degree. You can use your calculator. This around 92.3 meter per second. Okay, this is the horizontal component of the object. This is the horizontal component already, its values constant. Alright. Now what about the vertical? We are under the given. For the vertical, we have v naught across the y is equal to v naught times sine theta. Just v naught already we have 150 meter per second, because here the red color shows the decomposition of the velocity for the horizontal and for the vertical, okay. Times sine 38 degree. Now we have, with our calculator we can calculate around, it gets 180.2 meter per second. Now you have this given quantities, okay. So take out the given. Always when you do projectile motion, do the like this, okay. Given the take out all things and calculate the v naught x and v naught y, okay. It is very important. The next step, and let me in the new slide, you are required under A, you are required what is compute the flight time for the cannon. Now time of flight for the cannon, that means the total time of flight is equal to how much? Now solution, let me divide. Solution, we already the object already launched up to here, and then down. That means we have equation. That means let's say the y minus y initial is equal to v naught t v naught across the y times t minus 1 over 2 g t square. Let me, what is y? Y means here we have when the object projected upward above 72 meters. Let's say we said at the beginning y naught, okay? Y naught is this one, the initial displacement through the vertical. Let's say this y at the final, that means after projected from this point to this point, there is a height, or let's say y, okay? Now in our equation, y minus y naught, y means the total. Alright, let us solve the following example. Okay, here is our example. A cannonball is launched from the edge of the sea cliff of height 72 meters with initial speed 150 meters per second and angle 38 degrees above the horizontal as shown below. Assume you have this ball is projected above a certain height. This, let me say y naught, the initial displacement. Let's say to the part the vertical, the initial is 72 meters. Let me write here, given the initial displacement where the object projected above the ground is 72 meters, right? The angle theta 38 degree. What else? And with initial v naught, let's say, projected with velocity 150 meters per second. Now, and you know that we can with here we have this initial velocity, okay, and when the object is projected it has two velocities. For that means for the horizontal and for the vertical you have here the vertical, let's say vy across the horizontal we have vx, okay, let's say, and and now we are going to again calculate the vertical component and the horizontal component of this object. V naught y means V naught, the vertical component across the y means V naught times sine theta, which is equal to V naught already 150 meters per second times sine 38 degree. This almost equal to 92.3 meter per second. This is the vertical here. What about the horizontal? V naught across the x is equal to V naught times cos theta, which is always constant. This the horizontal component of the velocity is constant, which is equal to 150 meter per second times cos 38 degree, almost equal to 118.2 meter per second. Now we take out the given values. For example, during exams, they give you easily numbers that can be easily calculated. Okay, don't worry about the numbers. Now we take out the given. What's required? We are under A. Required. What's required? A, compute the flight time for the cannon of the ball. That means the cannon of the ball starts from here and then pass through and arrives here. We have the total time of flight. That total time of flight is required here. Okay, total time of flight, okay, is equal to how much? Okay, let me write solution. Now let me say this one. Let me say this. We have this initial from this point to this point. Let's say y naught, okay, and from this point to this point, let's say y. That means the maximum y, and we have here y final, okay. Now let's at this point at y final we have total time of flight. To calculate total time of flight, we have to use our equation. That means y final minus y initial. That means the displacement final minus the displacement initial, which is that means this displacement, you can find the change in displacement is equal to displacement final minus displacement initial. Yeah, definitely. So we are applying that equation, okay, displacement final, okay. So our motion is on the vertical. That means we have y, okay, y final minus y initial is equal to v naught across the y times t plus 1 over 2 g minus g t square, because minus is on the downward, always acceleration due to gravity is negative. So this one is coming from already we solved this equation, okay. The important thing, it depends the requirement. That means the total time of flight. So our reference point at this point, okay, at this point. So y final at this point, how much? From this to this, its value is what? 0, because at this point at y final its value is 0 minus y naught. Y naught means the initial displacement, that means the vertical initial displacement, this one, which is 72 meters, okay, minus 72 meter is equal to v naught y. V naught y we already calculated here, the initial the vertical component of the velocity, v naught times sine theta, which we already calculated, 92.3 meter per second times t plus minus 1 over 2, acceleration due to gravity is 9.8 meter per second square times t square. Now what's left? Let's take first 72 the right side. 0 is equal to 72 meter plus 92.3 meter per second times t minus 4.9. 1 over 2 times 9.8, 4.9 t squared. All right, now we are going to calculate using quadratic equation. So let's arrange again. Let's take 4.9 t squared towards let's change that place, okay? Or if we bring all to the left, we can write it as what? 4.9 t squared minus 92.3 meter per second times t, we have t, minus 72 meter is equal to 0. We can write like this, okay? So we can multiply all this one by a negative number, okay? By negative both sides, okay? No problem, okay? It's this one is not our problem. Now let me identify which. Now we have these values, okay? This value, and this value. We need to find the total time of flight. That means according to this can be found by the quadratic equation. That means minus b. That means our quadratic equation minus b plus or minus the square root of b square minus 4ac over 2a already is as simple. So we have a. The value of a is here 4.9, b minus 92.3, c is equal to minus 72 meter. So we can substitute all the values into this equation. Then this implies, and we take, don't forget, we take the time. The value of the time is positive, okay? So this the time can be calculated by equal to minus b means 92.3 plus or minus the square root of b square already 92.3. Sorry, my handwriting is poor, really. I'm sorry. 92.3 the whole square minus 4 times a. The value of a is 4.9 times c. The value of c is minus 72. This is under square root over 2a, 2 into a 4.9. Now we take only the positive values. That means which is equal to, using approximation, 19.6 seconds. That's the total time of flight to reach the ball until this point, okay? All right, the second question. Do you have any question before going to the next? Please say something. Okay, right. Okay, is it clear? Please say comment, okay? Stop any mic, okay, and say write on the comment, okay, according to our rules. All right, okay, good. So this one is clear. Okay, now B computes the range for the cannon. Oh, it's a good question, yeah. You are required to find out the range. The range means the horizontal distance. That means this is the range from the initial to the final horizontal distance. All right. Range B. Oh, sorry. B, the range is equal to how much? We can calculate the range from this equation. Okay, we know that the range is the horizontal distance. That means x is equal to x minus x naught is equal to v naught across the x times t plus 1 over 2 acceleration across the x times t square. We convert kinematics equation to the projectile motion. Now you know that for projectile motion, the velocity across the x is constant. This implies the acceleration across the horizontal is 0. Again, at this point, there is no starting point. That means the initial displacement is already 0. Now, we can rewrite this equation as this already 0. Again, this part already 0. What's left? The x, which is equal to the range, is equal to v naught times across the x times total time of flight. V naught across the x we already calculated as 118.2 meter. Okay, 118.2 meter per second times total time of flight we already calculated 19.6 times 19.6 second, here second by second. Okay, and the range is equal to 2320 meters around. Okay, that is the range, the value of the range. So always don't forget to calculate the initial velocities across the vertical and the horizontal. Okay, always. So simply we put what we calculated there. Okay, all right, that's about some parts of the calculation. I would like to give you homework. Okay, this is your homework. Okay, do it and send me with messenger. Okay, I will reply to you. Okay, if you have any question, you are welcome. Okay, you already compute the maximum height of the ball above the sea. You are required to find out the maximum height. Okay, why maximum? Or you can see this is the y maximum from this point to this point. Let me show you maximum, the maximum height, including y naught and y all, because from this point to this point we have another small y. Okay, let me say y1. Okay, y max, y1 plus y2. Okay, the second, you are required to find the speed when the ball hits the water. Okay, here the final speed when it hits the water. That means uh, this part is the water part. Okay, now when it arrives here, what will be the velocity or the speed you are required? Okay, at this point, okay, at point C, let me say A, B, B, C, at point C, at point C. You may use, for example, there are tricks. That means, uh, let me show you some information. Here we have two velocities, V across X and V across Y. Okay, so you are required to find out the speed of when it hits, not the vertical, not the horizontal, but the combination of the speeds. Okay, the combination of the speeds. You may apply V is equal to the square root of the velocity across the X square plus the velocity across the Y square. This is the information. Okay, so do it and send me. That's all we have for today. Next time we will start another topic. For this projectile motion scenario, we have all here. Okay, sometimes the robot will teach you